Okay, so we're going to do a factoring recap. I'll say that again. All right, if I'm talking to you guys and you're like, I already know all this, fantastic. If I'm saying some things and you're like, oh, I don't remember that or whatever, okay, great. This is what I want you to write down, please. When you're factoring, guys, when we have to find the zeros, the solutions, the roots, x-intercepts, all of those things mean to find out what x equals. 90% of the time we're going to factor. All right, we're going to get into in a second, well, not in a second, but tomorrow, starting about x-intercepts, where the graph crosses the x-axis. What are the solutions, the zeros, the roots? So when we talk about factoring, the first thing you ask yourself, is there a GCF? What does that mean, GCF? Greatest common factor. Okay, we always try and take out the letter and or number that they have in common. Makes our life a little easier, makes our numbers smaller. The second thing you look at is, do I have a quadratic that is a trinomial? All right, what does trinomial mean? How many terms is in a trinomial? 3. So that would be where we multiply a times c, and we factor into 2 binomials. I'll talk about this in a second. We're going to talk about when a is 1, when a is not 1. Then we come to what happens if we have 4 terms. How do we factor if we have 4 terms? We do grouping. Good. All right, we're going to talk about that a little bit. And then there's always those special patterns. Special patterns, we talk about perfect square trinomials or the difference of perfect squares. Difference of perfect squares. What does the word difference mean? Minus. It's got a minus sign. It's important to remember. If there's a plus in the middle, it changes things. We'll talk about that later. But when you're factoring, the first thing you should ask yourself, is there a GCF? Take the GCF out, factor it out, put it out in front, and then worry about all of the other stuff. So let's go down the left-hand side. I'm going to do all this with you. This is just a reminder, and then you guys are going to finish up the right-hand side. But again, please don't go ahead because I want to do the completing the square with you guys at the end. So I look at number 7. Number 7, number 7, number 7. Everybody with me? Is there a GCF? No. This is how many terms? 3. It's a trinomial. It's a quadratic. It's raised to the second power. So I'm going to say a times c. The number in front of your letter, p squared, is your a term. It's a 1. So 1 times 6. What are the factors of positive 6 that multiply to give me 6 but add to give me a negative 5? So p minus 6 and p plus 1, correct? You guys good? No? No, that's not right.
No, because it can.
So I'm glad we just did that. Look, what happens here? Negative 6 times 1 is negative 6. I don't want negative. I want it to be positive. What are some other factors, guys, that we could use? Ooh, negative 3. Good. P minus 3 and P minus 2. Oh, very good. What's negative 3 times negative 2? Positive 6. What's negative 3 plus negative 2? Negative 5. Good. Can you check and make sure that this is correct? Yes. FOIL this out. P times P is P squared. P times negative 2 is negative 2P. Negative 3 times P is negative 3P. Negative 3 and a negative 2 is plus 6. And then when we simplify, we should get what we started with. So we are good to go right here with our factors. Yes? Now, if we were going to solve, what would we do with each parenthesis? Set it equal to 0. All right, so look at number 9. Again, we're going to go through the steps of factoring. First thing I say is there a GCF? Is there?
Yes.
Yes. What can I take out of all 3 of these? A 3. If I divide out a 3, guys, I am dividing a 3 out of all 3 terms, but it doesn't go away. It's still there. It's just in a different spot. So now 15 divided by 3 is 5m squared 21 divided by 3 gives me 7m. And then 6 divided by 3 gives me 2, correct?
Yes.
All right, now we say, can we factor this more? Well, is this a trinomial? Yes. Is your a term 1? No. So I have to say a times c. 5 times 2 is how much? 10. What are the factors of 10 that multiply to give me 10, but add to give me 7? Okay, so I have m plus 5 and m plus 2. Now, things are a little different in this case because my a term is not 1. What do I have to do with this a term right here? Divide both factors that we found. This is how I factor when a is not 1. You guys may be taught a different way, but this is how I do it. So I'm left with 3 still on the outside. What is 5 divided by 5? 1. So I have m plus 1. And then 2 divided by 5 isn't pretty, so what happens here? 5 becomes my coefficient. So 5m plus 2. Questions? All right, let's look at number 11. GCF? No. Is this a trinomial that's a quadratic that we can just factor? Yes. Let's do a times c. 2 times 12 is 24. I need factors of positive 24 that multiply to give me 24, but add to give me 11. 8 and 3. 8 and 3. N plus 8, n plus 3. Now, guys, if you just left it like this, what's n times n? N squared. I don't want n squared. I want what? 2n squared. So remind yourself, ooh, I have to divide both of these factors by 2. So 8 divided by 2 gives me 4, right? So n plus 4. Does 3 divide by 2 pretty? No. Nope. So this comes out in front, and this becomes 2n plus 3. And again, you can FOIL that back out, and you should get what you originally started with. First question you ask yourself, number 13. First question we ask is there a? Okay, is there?
No.
So, a times c. Factors of negative 60, right? That multiply to give me negative 60, but add to give me 4. Crickets. What did we hear? What was that, Gianna? Yes, 10 and 6. Good. 10 and 6. Guys, if you don't know the factors of 60 off the top of your head, that's fine. Write them out. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Now, what can somehow give us a positive 4 in the middle? So I have P plus 10 and P minus 6, right? Okay, so now we're going to divide both of those factors by 4 since our a term is not 1. God bless you. Does 10 divide by 4 evenly?
No.
But can I simplify that?
Yeah.
Yes, what would that simplify to? 5 over 2, agreed. And then 6 divided by 4 doesn't work out evenly, but what can it simplify to?
3 over 2.
Good. And now I can rewrite my 2 parentheses as what? 2p plus 5, 2p minus 3. Perfect. If you guys didn't simplify the 10 over 4 and the 6 over 4, when you rewrote, like when you wrote your parentheses out, you'd have 4p plus 10 and then 4p minus 6, and then you would have to have seen at that point that you could have factored out a 2. So just try and simplify from the beginning. It's the easiest thing to do.
Denominator.
All right, GCF.
No.
Nope. Is this a trinomial where I could say a times c and factor pretty?
Yes.
Okay, let's see. 4 times 1. This is a tricky one. This always gets everybody. What are the factors of 4 that multiply to give you 4, but add to give you a negative 5? Say it again. Negative 4, negative 1. A lot of times people say 5 and 1 because they're trying to multiply. It's switched there. You want a positive 4. So negative 4 times negative 1 is 4. Negative 4 plus a negative 1, negative 5. Perfect. So I take this lovely a term, which is 4, and I'm going to divide both of the factors by my a term. 4 divided by 4 is? Good, so I have b minus 1. And then what happens with the 1/4? 4 goes to the front. Perfect. So 4b minus 1. Awesome. How can I check to make sure that I'm right? FOIL it back out. Good. All right, 17. Ooh, 17 looks different. GCF? No. Is this a trinomial where I could say a times c and go into 2 binomials? No. Are there 4 terms I have to group? No. So now we look and say, is this one of our special things? Is this the difference? What does difference mean? Is this the difference of 2 squares? This is the difference. Look, a minus sign is difference. Is this a perfect square and is this a perfect square?
Yes.
Yes. What gives me 9n squared? 3n and 3n. What gives me 25? 5 and 5. Now, difference of perfect squares, guys. You have 2 binomials that have the same factors, but their signs are what? Different. Plus and a minus. Does it matter where you put the plus, where you put the minus? No. The reason that this works, if I have 3n minus 5 and 3n plus 5, right? When we FOIL this out, I get 9n squared plus 15n minus 15n minus 25. What happens with my 15n's? They cancel out. That only happens if there's a minus sign in the middle. If there is a plus sign, it doesn't work out that both parentheses are the same. That would create a perfect squared trinomial, and that's not what we have. If you have 9n squared plus 25, that's not factorable. Has to be a minus sign in the middle of the perfect squares. So 19, we look at 19, we say, is this the difference of perfect squares? Is there a GCF? No. It's not a trinomial. There's no 4 terms for grouping. So I say, is this the difference of perfect squares? Yes. This is a minus sign in the middle. Great. So I have x and x. And then what gives me 9? 3 and 3. And my 2 parentheses are x plus 3, x minus 3. Can I write x minus 3, x plus 3? Yes. Either way is fine. All right, 21. GCF. Is there a GCF? No. Are there 3 terms? No, there's 4 terms. So what do? Group it, okay? First 2 and the second 2. Now there's a couple things we got to look at here. Right, when we're grouping, we're trying to create or trying to identify the GCF, which you'll see in a second. But I look at just this first parenthesis, 42a cubed minus 24a squared. What do they have in common? What can I take out of both of them? 6 what? 6a squared. Agreed. So I'm left with, divided by 6a squared, divided by 6a squared, and I'm left with 7a, agreed? Minus what? Minus 4. Now I look at my second parenthesis. It kind of already looks like the parenthesis that I have. But I'm leading here with a negative. If I lead with a negative, then I need to take a negative out. So what can I take out of negative 7a and a positive 4? I can take out a negative 1. And when I do, my signs change. So I have created a parenthesis that says 7a minus 4. What do you notice now? They're the same, right? I have 2 terms here. 6a squared times 7a minus 4 and negative 1 times 7a minus 4. 7a minus 4 is our GCF. So I take that out and I write it 1 time, just once. It is now gone, and what happens with the leftovers? They get their own parentheses. So 6a squared minus 1. Can I factor 6a squared minus 1 anymore? No. So there's my answer. Just saying, this is not the case, but just saying I had 7a minus 4, and then I had 4a squared minus 1. Is that completely factored? No. What 4a squared minus 1 is what? It's the difference of perfect squares. I can break that down a little more. This would be 2a plus 1 and 2a minus 1. I just created that own problem. This is just an example here. But always, always, always check, can I factor any more? Can I simplify this any more? Because what we're going to do from this point is to find our intercepts, you would now set each parenthesis equal to 0. And remember, what did I tell you guys? If I have something raised to the third power, how many solutions, roots, x-intercepts do I have? 3. Okay? Okay, now we're going to go to completing the square. Raise your hand if you have heard of completing the square. Okay. Keep your hand up if you remember how to do completing the square. Why did everyone's hands go down? Does anybody know why we use completing the square? All right, well, let's look at this. We're going to solve this. You see how it's equal to 0? Okay, so I want to solve this. Well, it's when we solve, we factor, right? So I have a squared plus 14a minus 51. This is a trinomial. All right, so a times c. 1 times negative 51. Well, what are the factors of negative 51 that multiply to give me negative 51 but add to give me 14?
3 times 17.
3 and 17. Okay, good. Now, if you didn't see that, right? If you didn't see that off the top of your head, if it didn't work out, you can always, always, always use completing the square. You have to use completing the square when things don't factor pretty. Or if the directions say, complete the square, all right? This does factor. I understand that, but that's not what we're working on right now. We are working on completing the square. So these problems down here, I want done by completing the square method. Here is how this works. Okay? You are going to first move your constant to the other side of the equal sign. So I'm going to rewrite this as a squared plus 14a plus, and I'm going to put a box. I'm going to put my square. When I move negative 51 to the other side, what does it become? Positive 51, okay? And then when we have an equation, an equal sign, all right, we want to stay equal. What you do to one side of the equation, you do where? To the other. So you notice I have a box on either side. All right, this is how we complete the square. You take this term right here, this middle term, and I'm going to say your b term divided by 2. What is 14 divided by 2? 7, okay? This is our magic number of 7. I'm going to rewrite this over here. I have my a, and then I have a positive 7, and we square it. And then in order to complete the square, you actually have to square the number that you got. What is 7 squared? 49. So I'm going to add 49 to this side. And what you do to one side of the equation, you do where, guys? So I'm going to add it over here. We're going to create an equivalency on both sides. What is 51 plus 49? 100. Okay, questions on how I just did that? We're going to do more, I promise. Now, guys, solve this. How would you solve this equation? I want to get a all by itself, so I do what? Take the square root. If you take the square root of one side, you take the square root of the other. So I'm left with a plus 7 equals what?
10.
What kind of 10? Plus or minus. Good, because you actually put the square root on. So how many answers? Look back at the very beginning. How many answers should I have for this problem? 2. So I'm going to say, you guys agree with me? I'm going to subtract 7 from both sides. Right? So I have a equals, well, let's say positive 10 minus 7, and a equals negative 10 minus 7. Agreed? Because it's plus or minus. So what's 10 minus 7? 3. And then what's negative 10 minus 7? Negative 17. That's where our 2 answers came from. If the directions say use completing the square, or you're told you have to do that, that's what you guys need to do. If it factors nicely, then you're fine. But let's look at this next one. Same thing. We're going to follow the exact same steps, all right? Complete the square. We're going to use completing the square. So the first thing I need to do is take 8 and do what with it? Move it where? To the other side. Great. So I have x squared plus 6x plus, well, I got to complete the square. So I'm going to put my box. Equals, when I move positive 8 to the other side, it becomes negative 8. And we got to be fair. What you do to one side, you do where? To the other. Okay, so I'm going to take my b term. My b term is 6. I'm going to divide it in half. So 6 divided by 2 is 3. Here comes that's our magic number. So in my parenthesis, I have x plus 3. The reason it's a plus is because it's positive. Squared, right? So I'm going to square 3 here. When I square 3, it becomes 9. So when I add 9 to one side, I add 9 where? To the other side. What's negative 8 plus 9? 1. And now in order to complete our problem, I want to solve for x. So what do I do to both sides? Take the square root. So I have x plus 3 equals. How many answers should I have? 2. What goes in front of my square root of 1? A plus or a minus. Very good. The last thing I'm going to do is subtract 3 from both sides, correct? So I have x equals, I have 1 minus 3, and I have x equals negative 1 minus 3. What are my two x values? Negative 2 and negative 4. And again, I know you guys, I could have factored that. I understand that. We're working on the concept of completing the square. All right, let's do 8. Trinomial, a times c. What are the factors of positive 23 that are going to multiply to give me 23, but add to give me negative 12? Anything? No. So this is why we have to use completing the square sometimes, guys. This doesn't factor nicely. You could also use the quadratic formula, but this doesn't factor nicely. So let's go through our process of completing the square. The first thing I do is take 23 and move it where? To the other side. So I have k squared minus 12k plus my box, because I'm going to complete the square, equals negative 23 plus what? Plus a box, because what you do to one side, you have to do to the other. So the process of completing the square, I take my b term, which is negative 12, and I divide it by 2, and I get what? Negative 6. So on the left-hand side of my my equation, what does my parenthesis look like? X minus 6 squared. Perfect. And then how do I finish this problem? What do I need to do? Square negative 6. When I square negative 6, what do I get? 36. So I'm going to add 36 here, and then I'm going to add 36 where? To the other side. Good. What's negative 23 plus 36?
13.
Positive 13. Agreed? You guys with me? All right. So now I want to solve for x. I'm going to take the square root of both sides. So I have x minus 6 equals. What goes in front of my square root of 13? Plus or minus. Good. Do you guys know the square root of 13? No, so just leave it. And now I have one more step. I have to add 6 to both sides. So I have two x values. One x value is going to be the square root of 13 plus 6. You can write it the other way if you want. Or the other x values would be negative square root of 13 plus 6. Those are my two intercepts. Those are my two solutions. That's where my graph crosses the x-axis twice. You can write, if you want to, 6 plus the square root of 13 or 6 minus the square root of 13. Those are both acceptable answers, however you would like to write it. Questions?
So you would add the number to the other side when you don't square whatever is there.
Which is the same thing we did in the other ones. It just, the other ones worked out to actually be able to simplify to a number.
Perfect. Thank you.
All right, guys, so completing the square. We need to be familiar with how to do that. It's a very simple process. It just takes a minute. Sometimes you're going to have to use completing this square. Sometimes you're not going to have to. But your homework right now, what I want you to do is to complete the rest of the problems and then just submit it to Canvas. We're going to start quadratics tomorrow, 2.1. Good?